Hello, my name is Samir Sai, and in this assessment, I selected the aircraft flight booking context. The aim of my prototype is to demonstrate a seating allocation algorithm for an aircraft. The main purpose of this algorithm is not to just to book any free seat, but also reduce single scattered empty seats. This is important because scattered single seats make it harder to seat couples or groups together later. For this prototype, I use a React and a white web application with TypeScript. The aircraft layout contains 30 rows and each row has 6 seats labeled from A to F with an easel between C and D. The rows are divided into different seat types. Rows 1 to 5 are business class, rows 6 to 15 and 18 to 27 are economy. Rows 16 and 17 are extra legroom and rows 28 to 30 are non-children rows. The algorithm also considers several constraints from the assessment. It supports booking for groups from 1 to 7 passengers. It tries to keep groups together. It avoids placing solo travelers in a way that creates unnecessary single seat gaps. It blocks restricted seating where needed, and it also includes an admin override to bypass normal rules when necessary. So now I will explain the logic briefly, showing the prototype. So the algorithm starts by creating the seat layout and assigning each seat a row number, seat column, side of the plane, seat type, and seat status. Some seats are marked as broken, and broken seats cannot normally be booked. Then, when a booking request is submitted, the system filters valid seats according to the passenger type, selected zone, and current seat availability. After that, the algorithm chooses seats differently depending on the booking size. If the booking is for one passenger, it checks individual seats and gives better priority to window or aisle seats because these are usually preferred by solo travelers. It also tries not to place a solo passenger in a middle position that will split a usual seat block. But if the booking is for 2 or 3 passengers, the algorithm searches within one side block, either A to C or D to F, so the group can stay adjacent on the same side of aircraft. If the booking is for 4 to 6 passengers, it searches across a full row. If the booking is for 7 passengers, one row is not enough, so the algorithm looks across 2 nearby rows and tries to keep the group as close together as possible. The algorithm doesn't simply take the first free seat, instead, it compares the candidate seat options and gives penalties to options that create isolated single seats, use multiple rows unnecessary, or place solo passengers in less suitable seats. The option with the lowest penalty is selected. On the left side of the screen, I have scenario controls. This allows me to switch between 3 presets: empty, half full, and nearly full. This is important because the assessment briefly specifies that the algorithm should be demonstrated in crowded situations, not only when the plane is empty. In the middle, I have the seating grid. Each seat is displayed visually and the color shows the seat types and status. For example, business, economy, extra legroom, no children, etc. On the right side, I have the booking request form where I can enter group size, passenger profile, preferred zone, and admin override. Firstly, I will show you the empty scenario. If I enter one adult passenger and allocate seats, the system chooses a suitable seat automatically. Next, I will switch to the half full scenario. This is more important because the plane already contains many booked seats. If I request a group booking, the algorithm tries to keep the passengers together while also avoiding creation of scattered single empty seats. Now I will switch to the nearly full scenario. This is the stress case. So here the available seats are more limited, so the algorithm must make more careful decisions. I can also show that when occupancy becomes high, The extra legroom discount becomes active. To conclude, this prototype demonstrates a working aircraft seat allocation algorithm that focuses on minimizing scattered single seats while also handling business rules such as broken seats, group allocations, no children rows, discount activation, and admin override.